Hello everyone, my name is Saurabh Pant. I teach chemistry in Sri Chaitanya Goshala campus and I hope you people are enjoying the inorganic sessions going on here, and for more enjoyment keep logging into your NCERT again and again, keep reading that again and again, better idea you will get. So till now what have you told, sir? So I will tell you, I told you about the physical property in the first part. We talked about the physical property. One very important thing what we learnt there, if we take PP bond, NN bond, imagine, then bhaiya, which bond will be stronger? Single bond. So single bond PP will be stronger. Single bond SS will be stronger. This is what we learnt in the first lecture. Why, sir? Why stronger? Simple. So bhaiya, nitrogen is very small. So the bond will also be very small. So what will happen? Here repulsion will happen. And because of that repulsion, because it is very close, this bond becomes easy to break. So less stable. So what about phosphorus? I'll tell you what about phosphorus here. For example, if you have phosphorus, phosphorus is very big atom. So the bond will also be large enough. So what will happen? Here the repulsion will be lesser because it is far away. So the bond is comparatively stronger. But when we compare, same logic works for sulfur also, oxygen also. But when we compare N2 and P2 there, we realized N2 was more stable because N2 contain a triple bond, and there we revised very quickly that bhaiya pi bond is made manchi by second period element and baga chadda by third period and later element. That was the main striking factor of the first lecture we read. Apart from that, ionization enthalpy variations, radius variations we saw. Second lecture, we talked about the chemical reactions, hydride. I told you a very nice, interesting story that NH3 felt guilty. Then for melting point, he topped, water topped, HF came second. But in the boiling point, water topped, HF topped because of hydrogen bonding. Ammonia felt very bad and he came third after SbH3. In this set of video, we are going to start with the chemical reaction, and I told you in this video I will tell you the most important thing, the most important and interesting thing. These are the tricks for writing the inorganic reaction. Sir, inorganic reactions can have the trick also. We don't have to mug them up. No, not anymore. Here I am here in front of you to tell you the method to write the chemical reaction with a single snap of finger without even mugging up a single thing. But for that, you have to see the video till the last, you have to understand everything, and the most important thing, you have to practice every day. So why don't we start immediately? Hello again. So in this segment of the video, I'm going to deal that topic which is the most frightful topic, that is reaction. Every student, when they come to the coaching institutes, when they come to the schools, to their teachers, they always ask, sir, what is the trick of remembering the reaction? So today, finally, I will do what you always wanted to know. That is, I'll tell you the tricks to remember the reaction in this whole lecture. I'll be just talking about the tricks of writing the reaction, and simultaneously I will cover all the reactions also in the same sequence as per NCERT. So stick with me, see the lecture till the last, and you will fall in the love for the science of chemistry. Let's carry on. So dekho yaar, the first trick that you have to remember is that from strong acid to weak acid, the conversions are spontaneous, and from stronger acid to weaker, not only strong, stronger to weaker, the conversions are spontaneous for the acid-base reaction. So the first trick is that, why? Simple yaar, stronger acid will have more tendency to give H+. So what will happen? If we have, let's say, one A- and a strong acid is there, so strong acid will give the H+ to the weaker acid and weaker acid will be formed. Weaker acid will not give the H+ in front of the stronger acid here. The stronger acid, that means the uncle acid and the uncle base, the elder one, will give the H+ to make the weaker one. First trick. Second trick, which we are going to use. Ammonium salt on heating, all the ammonium salts on heating, with the heating or with a strong base releases ammonia. So if you have an ammonium salt, if you heat it or you treat it with a strong base, ammonia is released. This second thing is again the trick which I used in the first case, ammonium salt with a strong base. Strong base will kick out a weak base, and ammonia is a weak base, it will be kicked out. So going ahead, let's take the first example. So you have urea. So listen carefully, I'm telling you how to write the reaction. All the reactions will write by ourselves. See now. So urea in aqueous medium or due to the moisture from the soil becomes ammonium carbonate. Now what will happen when ammonium carbonate is heated? So let's use the trick. There are so many reactions on the board, but just one trick we have to use, that ammonium salt on heating or with a strong base releases ammonia. So what thing will come out first? Ammonia bhai sahab will be released. So ammonia went. Let's carry on with the story. So I had NH4 and NH3 went away. I had NH4 plus, NH3 went away. So one hydrogen is left. So for 2 ammonium, 2 hydrogens are left. So what is left? So you can understand, sir, H2CO3 is left because NH3 went out. So what happens to H2CO3 are, this poor fellow happily breaks to form H2O plus CO2, and this is the clear cut reaction we have got. We have not mucked up anything. Directly by the logic, ammonia comes out, H2CO3 breaks to H2O plus CO2. Always remember that. Going ahead, NH4Cl with calcium hydroxide. Calcium hydroxide is a strong base. Sir, how do you know strong base? Arey bhai, first group, second group hydroxides are strong bases. So clear cut lallu logic. NH4Cl with calcium hydroxide, what will happen? Ammonium salt with a strong base release ammonia, so ammonia will come out. Sir, what about this? Same, ammonium salt on heating or with strong base, what will happen? Ammonia comes out. How to write the remaining reaction? Use the logic. You are very smart. You'll be able to understand here. Let's see now. From NH4Cl, if NH3 went out, what is left? HCl will be left. So HCl react with calcium hydroxide. Yeah, acid plus base, salt plus water. So CaCl2 plus water. What a brilliant logic you have used from class 9th. So bhaiya, NH3 went away, HCl left. So HCl plus calcium hydroxide, CaCl2 plus water came out. Carrying on, here also ammonia went out. How many ammonium there? 2 ammonium ions are there. 2 NH3 went, 2 hydrogen left. So H2SO4 plus NaOH. Arey yaar, in class 8, 9th you have done H2SO4 plus NaOH. Salt, Na2SO4 plus water will be left over there. So this is how you see how easily we have written all the reactions by one single logic. Ammonium salt on heating or with a strong base releases ammonia. Loved it. Remaining things will love even more. Carrying on. If anion is a good oxidizing agent, here the anions are not good oxidizing agents. But if the anions are good oxidizing agents, sir, what are those? MnO4 minus, Cr2O72 minus, world famous oxidizing agent, NO2 minus, ClO4 minus, IO3 minus are not important, you can ignore them. And sentimental NO3 minus. Twist will come at the last when sentimental NO3 minus will come. But what will happen when the oxidizing agent anions are there? They will oxidize ammonia further. So ammonia is further oxidized. So ammonium salt release ammonia, but that ammonia get oxidized by MnO4 minus, Cr2O72 minus, NO2 minus, ClO4 minus, IO3 minus and sentimental NO3 minus. Carrying on. For example, NH4Cl NaNO2. If I take this mixture, it is NH4NO2 only, na yaar? So NH4NO2. So one thing is sure, NaCl will come out. Useless, remove it. What about NH4NO2? Simple. Ammonium salt on heating or with a strong base release ammonia, but this NO2 minus being an oxidizing agent oxidizes ammonia. To understand, in ammonia nitrogen was in -3, it will be oxidized to 0 oxidation state, that is N2, and N2 gas comes out. So bhaiya, all of them, ammonium nitrite, ammonium dichromate, ammonium permanganate, ammonium chlorate, ammonium perchlorate, ammonium iodate, all of them release nitrogen gas because the ammonia got further oxidized. Lovely reaction. Going ahead, when you get this reaction, some byproducts are also formed like NO and HNO3, because sometimes what happens, oxidation go very vigorously and instead of stopping at 0, some of the nitrogen can go up to +2. If ever this kind of a thing happens, then what to do? So dekho yaar, HNO3 is not a problem. Why sir, why it is not a problem? It's an impurity na? Nahi, nitrogen is a gas. Okay? It's an impurity, I'm saying it's not important to remove it. Nitrogen is a gas, HNO3 is a liquid. So liquid will stay down, nitrogen gas will be up, you can remove the nitrogen gas easily. Main problem is NO, because NO is also a gas and nitrogen is also a gas. I have to separate him. What to do? Use a good oxidizing agent. What will happen? NO will get oxidized to HNO3. HNO3 is liquid, HNO3 remain HNO3. So bhaiya, all the impurity became liquid. Your nitrogen is a lovely gas. So remove the gas from the top, pour the liquid outside. Or in case you want to use for some other procedures, HNO3 you can use also. So understand how to remove impurity simply by oxidizing. Who is the actual impurity? Gas. Going ahead. Similarly, ammonium dichromate taken. So what will happen? Ammonium salt on heating releases ammonia. But Cr2O72 minus is oxidizing agent. He will oxidize ammonia into nitrogen, which is 0 oxidation state. Sir, what will happen to Cr2O72 minus? Arey bhai, if any person act like an oxidizing agent, he will himself get reduced. So +6 get reduced to +3, Cr2O3 comes out. What about the remaining part? Hydrogen, oxygen, they come out as water. Carrying on, what will happen to NO3 minus here? Understand, NO3 minus was seeing all this reaction. NO3 minus is a very respectable oxidizing agent, very respectable one in the families of oxidizing agent, NO3 minus. What happened when he saw that my own brother ammonium want to get oxidized and he's going to other people for oxidation, na? He becomes sentimental. He's from my family. He's from nitrogen family, NH4 plus, and ammonia want to get oxidized, and right now other people are acting like an oxidizing agent. So what happened? NO3 minus started crying. He started crying. He said, no, this is not good. I swear I will make my brother laugh. So what he does, when nitrate comes with ammonium salt, he understands that ammonium is ready to get oxidized. He becomes sentimental. He cries and he says that, bhaiya, ammonium salt, I will make him laugh. And he makes laughing gas. That is N2O. Chamka bhaiya. So NO3 minus oxidizes ammonium salt to further N2O, which is in +1. So these remaining people stop at N2. NO3 minus becomes sentimental. He oxidizes further to laughing gas. One question come now. These are the preparation methods of, you can see, ammonia, preparation methods of nitrogen, all over. In fact, preparation method of laughing gas also over. All are there in the NCERT. Drying of ammonia. What can you use for drying of ammonia? Very standard question. So bhaiya dekho, CaCl2 cannot be used. Why? Because Ca2 plus here forms a complex with ammonia. P4O10 cannot be used. H2SO4 cannot be used. Dekho, drying of ammonia means I want to remove water. I don't want ammonia to get affected. I want just water to be removed. P4O10, H2SO4 are good dehydrating agent, but it is a non-metal oxide, and non-metal oxides are acidic in nature, and H2SO4 is a sakshat acid. So he is also acidic in nature. So this acidic in nature will react with ammonia. I don't want, I just want the water to be removed. So bhaiya, the only option left is calcium oxide. He is basic in nature. He will not react with ammonia, and this CaO does not form any complex with NH3. So this was about the basic tricks. Let us carry on. So by this time, you people are expert in writing the ammonium salt reactions. Understand, better you practice, the better you become in that topic. So see that part again, practice it again and again. But let's carry on. So there are two other methods of preparation of nitrogen and ammonia. Let's focus upon that. You already know them also. In case you don't know, right now you can use barium azide, sodium azide. What is azide ion? N3 minus is called azide ion. And if I give H plus to him, then this thing is called hydrozoic acid. Hydrozoic acid. So when this N3 minus compounds are made azide and heated, what will happen? Very, very pure nitrogen gas comes out, and barium and sodium go out as it is. So sodium azide, barium azide heating will give you the purest form of nitrogen that you need. Coming to the next reaction, N2 plus H2 gives you ammonia. This is known as Haber's process. So understand this thing. In the Haber process, the catalyst we use is K2O, Al2O3, and the iron oxides are the catalyst there. You might have read this thing in the surface chemistry also. Also, this thing is there in the nitrogen family as well. So it's a very important topic. So half N2 with 3 by 2 H2 gives you 1 NH3. Enthalpy of formation is minus 46 kilojoule per mole. This one small revision I'm going to give you of the chemical equilibrium part, Le-Chatelier principle. So let us understand. What is the optimum condition for what is the condition for the optimum yield? For optimum yield of this reaction, of optimum yield of ammonia, for more production of ammonia, what is the condition? Let's understand. So enthalpy of formation is negative. So what the logic is there for Le-Chatelier principle? If the temperature is decreased, reaction will go towards exothermic direction. So if the temperature decreases, reaction goes towards exothermic direction. So bhaiya, exothermic direction here is forward reaction. So at low temperature, reaction will go forward. But the problem is there, yaar. Problem is there that at very low temperature, if the temperature is too much lowered down, what will happen? Reaction speed, we call it reactivity, or the speed of the reaction decreases. You can understand, if the temperature is very low, molecules will move very, very slowly. La 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 kind of thing they will do, and softly they will touch and they will go away. So we don't want this kind of a thing happening there. We want them to colloid and react. So bhaiya, temperature cannot be very low also. But sir, it's a problem now. Why? Le-Chatelier uncle is saying temperature low, reaction goes more forward towards exothermic direction. And you are saying, sir, speed of the reaction will become very low. Yes. So you have to come in the middle somewhere. So we take moderate temperature. And here the moderate temperature is 700 Kelvin. But so 700 Kelvin is very high temperature. Yeah, they are gases. They can easily handle 700, 800 Kelvin easily. In the sun also you have helium gas and thousands of degrees Celsius is there. So don't worry about the gases. 700 Kelvin is a moderate temperature for them. So what will happen? At moderate temperature we take. Why moderate temperature? Why not low? Because if we take very low temperature, reaction speed decreases too much and the ammonia will be produced. A lot of ammonia will be produced, but will be produced after many years. We don't want that. In the industrial method, we want more ammonia and faster also. So, bhaiya, temperature lesser, reaction will go forward more and more, but the speed will become very slow. So, we take moderate temperature. Second thing, here total we have 2 moles, you can see. 1/2, 3/2 total, 2 moles. Here we have 1 mole. So, basically on the product side, moles are less. So, if you want the reaction to go forward, compress the reaction. So, if you compress the reaction will adjust and will go towards lesser number of moles. So, bhaiya, the second condition for the reaction to go more and more forward is high pressure. So, if the reaction is conducted at high pressure, if the pressure increases, what happened to the reaction? The reaction go towards the lesser moles, wherever the moles are less. So, under high pressure, the gas will get compressed and the reaction goes towards lesser number of moles. So, we understand here lesser moles are on the right side. So, at high pressure, reaction will go more and more forward. So, what we understand, at a very high pressure of 200 atm, we conduct this reaction. So, these are the conditions for the optimum yield of the Haber process. Same logic I can apply for contact process also. In the oxygen family, I will teach you that thing in detail. That SO2 plus half O2 SO3, this reaction is there. It is also exothermic. So, temperature less, reaction goes forward, but very low temperature, reaction speed decrease. So, we take moderate temperature. And 1.5 moles here, 1 mole here, you want it to go forward, compress it, increase pressure, reaction goes towards lesser number of moles, that is forward. So, here also the pressure taken high, the temperature taken moderate. Why moderate? Because at low temperature, yield is very good, speed is not good. Going ahead. Nitrogen, bhai sahab, is a pseudo-inert gas. Why? Because nitrogen, bhai sahab, has a triple bond and breaking this triple bond at room temperature is bhaiya impossible. It's a very high bond enthalpy of 941.4 kilojoule per mole. Very high. So, what happens when you heat lithium or magnesium or other metals with nitrogen, nitrides can be formed, but sodium to cesium, you have read in the S block, quick revision. Sodium to cesium does not form the nitride directly with the reaction with nitrogen. So, lithium react directly with the nitrogen to form nitride. Diagonal relationship, magnesium and the whole second group also react directly with the nitrogen to form their nitride. What will happen if I add them to water? For this, wait for the next lecture. I will tell you in the next lecture the small trick of writing the hydrolysis reaction. You will love that trick also. For this lecture, ammonium trick is more than enough. Next lecture, new trick you will learn. Anyway, so they will form nitride. Sodium, cesium will not form nitride directly. Ammonia dot water. Mixture of ammonia and water is written as NH4OH. So, what happens? Cr. Zinc and iron, they are moderately reactive metals. Moderately reactive. Electrochemistry, very recently you have seen. Electrochemical series also you know. So, S block, aluminium comes in the beginning. Then zinc, iron, tin, lead will come. Then copper, happa. I like to call copper, happa. They are the less reactive, low reactive metal. Who are this copper, happa, sir? Copper is copper. Then we have Hg, Ag, Pt, Pd and Au. These are copper happa. So, these are low reactive metal. So, ammonia behaves in a different way with both of them. Why? Bhaiya, ammonia is a Rajnikant. Like the superstar Rajnikant, he can also behave in multiple ways. How? He can act like a base. He can give OH minus. So, Zn2 plus with moderately reactive metal salts, he give OH minus and form precipitate. Sir, why precipitate? How would we know? Dekho yaar, hydroxides of only first and second group are soluble. Only they are the strong bases. Remaining all the metal hydroxides are weak base. Weak base means not dissociated 100%, means they will be precipitated. So, going ahead, ZnSO4 took OH minus, became ZnOH whole twice. FeCl3 took OH minus, it will become FeOH whole thrice. Now, this is hydroxide. What is hydroxide? Hydroxide is hydrated oxide. So, hydroxide is hydrated oxide. तो भैया ये लो hydrated oxide. तो भैया zinc forms hydroxide, iron form hydrated oxide. Both are same only. Both you can represent in the same way. Color also we have to remember, क्या sir? हाँ, but let's remember the byproduct first. So, ammonium sulfate, one byproduct. Ammonium chloride, second byproduct. What about the color? Simple here. Simple thing is there, in D and F you will learn this thing, that D0 and D10 configurations are mostly colorless. D0 and D10 configurations are mostly colorless. So here zinc 2 plus has a D10 configuration. Ag plus also has D10 configuration. So Ag plus compound and Zn2 plus compound, they are white in color, easily remembered. Chaliye, okay sir, nice logic you have told about D10, we can remember sir, what about this brown color? This to you have to mug up na. Arey nahi yaar, this is rust. Around you when you see the rust, what's the color of rust? Purple kya? Or blue? Rust is brown only in color. From daily life you are seeing it. So this is the rust in front of you and the color of rust is brown. This is how it reacts. With low reactive metal, what happens? Ammonia act like a ligand. NH3 act like a ligand. Coordination compound, if it is over, you will understand easily. Otherwise, just remember it. Copper in +2 and Ag is in +1 here. So what happens with copper happa? NH3 forms a complex. +2 means 4 ammonia will come. +1 means 2 ammonia will come. So more charge, more ammonia will come. Less charge, less ammonia will come. So here CuNH3 whole 4 is made. Color, very well we know copper salts are mostly blue in color. So CuNH3 whole 4 is deep blue in color. AgCl with ammonia, AgNH3 whole twice plus and white in color. Understand here, this is a PPT. So you can understand this container had a precipitate of AgCl. You added and it was aqueous solution. AgCl PPT was there. You added ammonia. What happened? Bhaiya, magically all the AgCl got dissolved in the aqueous medium only. Why? Because as soon as ammonia comes down, ammonia reacts with AgCl. As soon as ammonia reacts with AgCl, it forms a complex and this is 100% soluble in water. So AgCl PPT miraculously disappeared on adding X. Who is X? X is your ammonia. So this was the basic reactions. Now this practice will make you very good in the chemical reactions also. I'm just giving my try to generate some interest in the inorganic chemistry, but I need your full support. Read the NCERT very well. Try all the reactions by yourself, also using the same logic which you learned today. So let's carry on. So by this time we have seen the chemical reactions, the logic behind the chemical reactions, the actual beauty of the inorganic chemistry. Now I'm going to tell you about the allotropes of phosphorus. So let's see a quick review here. So see here, allotropes of phosphorus, the most commonly found allotrope of phosphorus is white phosphorus, a little yellowish in color but looks kind of white, so we call it white phosphorus. White phosphorus exists like P4. In the beginning first lecture also I told you the structure of P4 something like this. Now what happens? Here phosphorus is having Sp3 hybridization. Sir, how can you say Sp3? Because you can see here each phosphorus make 3 sigma bond and has 1 lone pair. So steric number comes as 3 sigma plus 1 lone pair, that is 4 steric number, and for 4 steric number we have Sp3 hybridization. Now what is the angle for Sp3 hybridization? So the angle should be 109.5 degree for Sp3. But this poor fellow, this phosphorus here, he has to maintain an angle of 60 degree. So I want to be at 109.5 degree away from each other, but I have to stay at 60 degrees, so it isn't too much of angle strain. It want to open up, it want to become 109.5 degree. Because of that, there is something known as angle strain. So understand here, angle has to be 109.5 degree, it is actually 60 degree, so around 49.5 degree of angle strain is there. That means the angle want to expand by 49 more degree here. Because of which, P4 is bhaiya highly reactive. Highly reactive P4 is. Why? Because the angle want to expand itself. So what happens here? P4, what he does? Think about it. If this is the angle 60 degree, I want to expand the angle, what should I do? So what happens actually is that, imagine I have these joints here, and if I use my joints, see properly out. If I use my joints, then without changing the distance of my fist from each other, I am able to generate an extra angle. That means if this phosphorus bond can get a joint in the middle, it can increase the angle to 109.5 degree, and this smartly he also plays the game. He reacts with the oxygen. What happens here? When he reacts with the oxygen, this thing glows in the dark. This white phosphorus, this start glowing in dark. Why? Because when he reacts with oxygen, he desperately reacts here. Why? Angle strain is there. Somehow he has to create a joint to increase the angle, and bhaiya, in this desperation, he releases a lot of energy. That angle strain, how it is removed, you can check. All the PP bonds, fit one oxygen there as a joint. So this beautiful, lovely, awesome structure comes out like this. So what happened? For every joint, I put one oxygen. So firstly, P4O6 is formed. Further oxidation, this double bond O will come here as well. And you get finally P4O10. See how beautifully I drew the structure. P4 as it is, and for every bond of PP, I attached one oxygen in the middle so that the angle strain is now released. So this P4 is very happy now. P4O10 formed here. What happens? Angle strain is there, highly reactive, and it glows in the dark. Next, how to convert white phosphorus to red phosphorus? Heat it for several days at 573 Kelvin in the inert atmosphere. Why inert? I don't want my P4 to react with someone else. I want him to rearrange itself to form another allotrope, so red phosphorus will be formed. Will he glow in the dark? No. What happens in red phosphorus? One of this bond, PP, get broken down. Let's say this bond got broken down and it got extended as a linear chain. So it's polymeric in nature. That's why the reactivity is a little less and stability is a little more. So it does not glow in the dark. He reacts with oxygen, but that excessively heat release is not there. That glowing does not happen. Apart from that, white phosphorus is soluble in CS2 but not in water. Why, sir? Like dissolves like. He is a non-polar compound soluble in the organic solvent, not the polar protic solvent. Ionic compounds are soluble in water. Then, the red phosphorus is neither soluble in CS2 nor in water. Very important question. The difference between red and white phosphorus is that white phosphorus soluble in CS2, not in water. Red phosphorus soluble not in CS2, not in water. Why, sir? Water we can understand. It is non-polar, so will not be soluble in water. Sir, what is your comment about CS2? It is polymeric here. So polymeric substances have so much large mass that they do not get soluble easily. They stay together as a precipitate. Next, what? If you heat red phosphorus in a sealed tube for 803 Kelvin temperature, you get one type of black phosphorus, that is alpha black. Alpha black is highly stable. What happens here? This bond also break and the whole network like structure get formed. And in the alpha black phosphorus, it does not get oxidized in the air. Sublimation is possible. It is opaque, you can't see through it. Monoclinic or rhombohedral structure is there. Sir, I don't know what is monoclinic rhombohedral. Maybe after reading solid state, you will understand. Then, stability wise, black is most stable, then red, then white, because white have maximum angle strain. Red has only one bond left for little bit angle strain. Black phosphorus, no angle strain at all. All the bonds in the middle are broken down. Everyone is happily moving their hands here and there. Next, if you take white phosphorus for 473 Kelvin at high pressure, another type of black phosphorus, beta black, comes. And this beta black phosphorus doesn't burn up to 673 Kelvin. That is why, and after that it can burn. That means taking a temperature of 803 Kelvin is not a good idea to prepare beta black, because he will burn after 673. So what we do? We increase the pressure, and at a lower temperature, after reaction of white phosphorus, at a lower temperature but higher pressure, you can get the beta black phosphorus. This thing, I have simplified it for you. You have to note down this thing from here, from the board also. Make sure this thing is in a very complicated way written in the NCERT. So if you can remember this flow chart, this table, it will be very easy for you to remember it. So this marks the end of this topic here, this lecture here. Hope the initial reaction part was very interesting to see, and this ND part is very, very informative for us. Understand here now that for the next lecture, I'll be talking about more and more compounds of nitrogen family. But before that, make sure that you read the NCERT up to here. You try to do your material simultaneously, because for the groups, the best thing is multiple reading of the same thing. You attended the lecture. By the end of third lecture, little bit logics will start generating on the head. But now those logics have to be applied by reading the NCERT again and again. And believe me or not, you will become expert in the inorganic chemistry. All over India, you will start rocking in the NEET examination. So, bhaiya, we'll meet in the next lecture now. This is Saurabh Pant signing off. Thank you. Stay safe, be at home, and come healthy when you come back here to the campus. Thank you so much.